All right, College Algebra, welcome to your Monday, January 9th, 2023 notes video. For today, we are starting on page 12. We are starting on page 12 here. All right, today we are brought to you by in-house sponsors, Noon Electrolytes Tablets, Sport Hydration. The finest point guard that ever lived, John Stockton, Hall of Famer, and the great Hall of Famer, Lou Brock. Thank you, Utah Jazz and St. Louis Cardinals for being in the house. Anyway, page 12 by now should be a review. Okay, so what are we going to do? Again, it says section 5 to review. At the top, it says divide. So on number 1 here, we're going to divide all of those terms, 3 up top, 1 down below, by 5x squared, by 5x squared. So we're going to divide 15 by 5. We're going to get 3. We're going to take 2 away from 10. The top has more x's, has 8 more. 3x to the 8th minus 5 divided by 5 is 1. X to the 3rd divided by x squared is just x, plus 40 divided by 5 is 8, and the x squareds cancel. All right? On number 2, you're going to divide all 3 terms up top and really down below. Okay, so that's why the denominator is going to go, because 6x divided by 6x is 1. You're going to divide everything by 6x. 36 divided by 6 is 6. X to the 8th divided by x. X is 7th. You got more x's up top. 8 minus 1, 7. Plus 18 divided by 6 is 3. 4 minus 1 with the x's. X to the 3rd minus 6 divided by 6 is 1. X to the 3rd divided by x is x squared. 3 x's here, just 1 there. 2 up top remain. All right, so now on 3 through 6, we have a little something called synthetic division, okay? That's what we learned. Again, there's another technique, long division, that if you take pre-calculus, you might need to know, but synthetic division is going to work well for us here. So what we do here, we're testing whether or not x plus 3, or if you set x plus 3 equal to 0, we're seeing whether x equals negative 3 is a solution. So I set, when I'm dividing by x plus 3, I set that equal to 0. Negative 3 goes in my cubby. Remember, I'm doing 3x to the 3rd divided by a single x. What's 3 divided by 1? It's 3. That's why we bring this number down, if that is a single x, which the ones I give you this year will, in fact, be. So why did I write 3, 7, negative 4, and 3? Well, 3 for 3x to the 3rd, 7 for 7x squared, negative 4 for negative 4x, and 3 for the constant 3. So I bring down the 3. Then I do 2 operations the whole time. I multiply. I take negative 3 times 3. That's a negative 9. And then I add. 7 plus a negative 9 is a negative 2. Negative 3 times a negative 2 is 6. And then I add 2. Negative 3 times 2 is a negative 6. And then I add negative 3. So negative 3 is the remainder. So x plus 3 is not a factor. X equals negative 3 is not a solution. So what do these numbers down here mean? Folks, I did 3x to the 3rd divided by x. I got to lose a power. So my answer is going to begin with not 3x to the 3rd, but 3x to the 1 power less, 3x squared. So that's a 3x squared minus 2x, positive 2 plus 2 minus 3 over what I'm dividing by. Okay? That's the name of the game, synthetic division. Can only get harder if we have to add in some zeros. So we're taking x to the 4th minus 3x to the 3rd minus 11x squared plus 3x plus 10. We're going to divide it by x minus 5. All right, I'm going to take x minus 5. I'm going to set it equal to 0. X equals 5 goes into the cubby. 5 goes right there. 1x to the 4th, right? So I do 1x to the 4th divided by 1x. That's just 1. Remember, I always bring this number down. 5 times 1 is 5. Add them up. 2. 5 times 2 is 10. Add them up. Negative 1. 5 times negative 1 is negative 5. Add them up. Negative 2. 5 times a negative 2 is a negative 10. Add them up. You get 0. So x minus 5 is, in fact, a factor. X equals 5 is a solution. What's my answer going to be? I have x to the 4th. I divided by x. My answer is going to be 1 power less. X to the 3rd plus 2x squared minus x minus 2. All right. Got x to the fourth minus 3x squared plus 5x minus 6 divided by x plus 2. I'm going to set x plus 2 equal to 0. I get x equals negative 2. Negative 2 goes in the cubby. 1x to the fourth, negative 3x to the third. Folks, there is no x squared term, so I have to put a 0. I can't skip it. I got to put a 0 for 0x squared. 5x negative 6. I bring the 1 down. Negative 2 times 1 is a negative 2. Add them up. Negative 2 times negative 10, or 5 is a positive 10. Add them up. Negative 2 times 10 is a negative 20. Add those up. And negative 2 times negative 15 is 30. Add them up. 24 is your remainder. So x to the third minus 5x squared plus 10x minus 15 plus 24 over x plus 2. All right, this next one, I set x plus 4 equal to 0. Negative 4 goes in my cubby. 1x to the third, 3x squared, negative 5x, negative 4. Bring down the 1. Negative 4 times 1 is negative 4. Add them up. Negative 4 times negative 1 is 4. Add them up. Negative 4 times negative 1 is 4. Add them up. 0 is my remainder, so this is a factor. This is a solution. 1x squared, because it's x to the third. 1x squared minus x minus 1 is my answer. All right, a real good review over synthetic division. Let's take a look here on 7. Just going to divide everything by 3x. 27 divided by 3 is 9. X to the third over x. X squared plus 18 divided by 3 is 6. X squared divided by x. X minus 9 divided by 3 is 3. And the x's will cancel. On 8, I'm going to divide everything. I'm going to, again, see if I can divide everything by that denominator. Everything can be divisible, is divisible by 5. Every term has at least x squared. Every term has at least y squared. 40 divided by 5 is 8. Subtract the powers. There's 3 x's versus 2, so 1 power of x remains. Y squareds cancel. Plus 25 divided by 5 is 5. X to the fourth over x squared is x squared. Y to the fifth over y to the second is y to the third. That is page 12. That is a good review there. All right, so then we got this next page. Next page here, just turn it. I believe there's a 13 at the bottom. I did skip some pages in here. I made it a lot shorter than years past, believe me or not. All right. That coffee break brought to you by Keurig. Go Keurig. So, I just messed up. Sorry, that just messed up the screen. Come on, get back. Get focused. All right. Anyway, I'm going to divide everything by 8. X to the second, y to the second. 24 divided by 8 is 3. The y to the seconds cancel. X to the seventh over x squared is x to the fifth minus. 40 divided by 8 is 5. The x squareds cancel. Y to the third over y squared is y. Now, kind of an issue on number 2, that every single term does not have x to the third. So I wrote that down first. Divide everything by 5x to the third y. There's a few different ways you can write this answer. First way is how I did here. You can do 35 divided by 5 is 7. There's actually more x's at the bottom, so there is a denominator here, x squared. Y to the fourth divided by y is y to the third plus 6 divided by 5 is 12. The x to the thirds cancel, and there's one more y up top. Now, because every term here does not have x to the third, you can divide everything by everything at least has at least a 5, right? You could have divided by just a single x instead, leaving you with this. You're going to divide everything, so you're going to divide, you can say divide all by 5xy. Right, so if you divide everything by 5xy, then down below, there's that x squared. And then you do 6 divided by 5 is 12. And then you have x squared, y squared. I'm sorry, x squared, y. All right, this is the same answer. This is actually simplified better. All right, so the way I did it first and 2, I think is the way to go. And we've got number 3 here, folks, a little synthetic division. Set x minus 2 equal to 0. Put 2 in the cubby. 3x to the third, negative 7x squared, 6x and 8. Bring down the 3. 2 times 3 is 6. Add them up. 2 times negative 1 is a negative 2. Add them up. 2 times 4 is 8. Add them up. 16 is your remainder. So 3x squared minus x plus 4 plus 16 over what I'm dividing by, x minus 2. Number 4, I don't like the 2x minus 3 there. You get a free point. Put ghost Lukey's. All right, so number 5, negative 8 times a negative 6 is not 4, but 48. Then we're going to add the exponents. Add the exponent. X to the 4th times x to the negative 3rd. Add the exponents is x to the 1st. Y to the 2nd times y to the 1st is y to the 3rd. Z to the 1st times z to the 4th is z to the 5th. All right, that was our first exponent rule, and I think this was our second or third exponent rule from that very first page. Power to the power, I multiply the power, so 5 squared is 25. I multiply those two powers together, that's x to the 8th. I multiply those two powers together, y to the 4th. I do 3 to the 3rd power, that's 27. Multiply those exponents together. Multiply those exponents together. Now I'm multiplying with the same basis. First I multiply 25 times 27, that's 675. Then I add the exponents, 8 plus 6, x to the 14th, 4 plus 12, y to the 16th. All right, on 7, what you really want to do first on 7, folks, is clean that up as best you can. 21 divided by 7 is 3 up top. All right, there are more x's up top by 3. There are more y's up top by 5. There are more z's up top by 6, not 4. 1 minus a negative 5 is 6. So there's no more denominator when you clean that up first. Then I still have to cube everything, okay? So I simplify this. Now I have to raise everything to the 3rd. 3 to the 3rd is 27. Power to a power, multiply them. Power to a power, multiply them. Power to a power, multiply those exponents. There you go. Negative 35 divided by negative 7 is 5. Positive 5. 1 minus a negative 2 is 3. 4 minus 2 is 2. 5 minus a negative 8, 13. All right, no more denominator again. That's division property. You subtract the exponents. Then we actually have a new section. They want you to notice that synthetic division, the remainder when you synthetically divide, is in fact the number you would get if you plug that number in the cubby into the original function. Well, folks, if you ever saw this on the SAT, you just plug it in. So, oh, we got an announcement here. Maybe. This bad boy will not be edited out. So P of negative 4 and P of 2. Hopefully there's no fire alarm. P of negative 4 and P of 2. That's all you're going to do. You're gonna plug negative 4 in for x. Oh, they're testing. This is going to be great. You're going to plug negative 4 in for x, get an answer. You're going to plug 2 in for x. Make sure you have all this work and get an answer. That's all we're going to do. If we did synthetic division, we put a 1 for 1x to the 4th, 0x to the 3rd, negative 2x squared, 0x and 3. We do synthetic division. Our remainder would be 227 for the first one and 11 for the next one. But again, when we're thinking about that SAT, if you see P of negative 4, P of 2, all you're going to do is plug negative 4 and 2 in for x. Remember, when you raise something to, raise a negative to an odd power, your answer there stays negative. Okay, those don't need any explanation. That's all from chapter 1 and 2. That is nothing new. That is nothing new. Take a look at 3. P of negative 4, P of 2. Plug negative 4 in for x. It's the opposite of a negative answer. That is a positive answer. So take your time there. Again, pause this if you need to. And there's 4. Then we're going to talk about something that is new and very, very easy to end here. New and very, very easy. P of negative 4 is blank. P of 2, blank. All right, state the degree and leading coefficient. The degree and leading coefficient. Folks, the degree is simply the highest power. The degree is the highest power. What is the degree? The highest power. Now, these might not go in order. They might not be written in standard form. What's the highest power? The highest power is 3. X is second. This is x to the 0. So 3 is the degree. And what's the leading coefficient? It's the number attached to the highest power. Positive 15. LC for leading coefficient. The degree is 3. 6, it is written out of order. What's the highest power? The highest power is 8. So the degree is 8. What's the leading coefficient? Negative 2. What is attached to x to the 8th? A negative 2 is the leading coefficient. Number 7, what's the highest power? Highest power is 9. The degree is 9. What's the leading coefficient? 7. Now, folks, you could FOIL this out. First out or last. You could get 8x to the 4th plus 10x to the 3rd minus 16x to the 3rd minus 20x squared. So then you would have 8x to the 4th. Awesome. Minus 6x to the 3rd minus 20x squared. Anyway, what I know is I know that the highest power here times the highest power there is going to give me my highest power. So 8x to the 4th is what it's all about. My degree is 4. My leading coefficient is 8. And I just have 2 very quick and easy pages. So take a look at this top. Given the degree, odd degree, even degree, and the sign of its leading coefficient, positive odd degree, negative odd degree, positive even degree, negative even degree. That's the ending behavior of your graph. You know, your graphs could go like this. Ending behavior would be up, you know, down and up. Your graph could go like this, a parabola, up, up. Your graph could go like this, down, down. Okay, so that's what we're going to do. We're just going to strive the end behavior. We're going to give one of these answers here, all right? So they can be very quick. So what I did is I started it for us, and I'll finish it here. So given the polynomial function, describe the end behavior of its graph. All right, so these are all written in standard form. We take a look here at the leading coefficient. Leading coefficient is, hey, yeah, go ahead. I'm making a video. That's all right. You can.
Sure, quick question.
All right, quick question. Yeah, I'm not going
to. No, I didn't even see you talking. Oh, what does this mean?
Oh, so you're gonna do like 2 minutes at half marathon pace, then you're gonna do a minute easy.
Okay.
Then you're gonna like half the time recovery. Then you're gonna do 4 minutes at your half marathon pace, then 2 minutes easy. 6 minutes at half marathon pace, 3 minutes easy. Yeah. So instead of 1-1 recovery, half. All right. All right. There we go. We are back there. Just a nice visit there from Mr. Elvers. We're talking about running, which is always the best. Okay. Folks, where were we? So, positive leading coefficient. Guys, if you have a leading coefficient that's positive, the graph ends by going up. Start there. The leading coefficient is positive, the graph ends by going up. Now, this is an odd degree. Odd degree, folks. Odd degree functions have opposite end behavior. Look, opposite direction, opposite direction. So, odd degree functions have opposite end behavior. That means if it ends by going up, it's going to go south in the other direction. All right. So, leading coefficient, negative, -3. Leading coefficient is negative. So if the leading coefficient is negative, the graph ends by going south. Now, this is an even degree function because 2 is even. Even degree. Folks, if you look up top, even degree functions have the same end behavior. So if it ends by going down, the other way goes down as well. And to see the leading coefficient is again negative. Ends by going down. X to the 5th. What is 5? 5 is odd. It's odd degree. It ends by going down. It's odd degree. It's going to go up in the other direction. And let's take a look at D. Leading coefficient is a +6. +6. 2 is your degree. The degree is even. Even degree. Even degree has the same end behavior. It ends by going up. The other way goes up. All right. E, the leading coefficient is negative, and the degree is odd. Odd degree function. So leading coefficient is negative. It ends by going south, and the other direction it would go up. Odd degree functions have opposite end behavior. And lastly, leading coefficient, that's a -5. Leading coefficient is negative, ends by going south. 4 is even. It's an even degree function. So the other direction, it's also going to go same. It's going to go same direction. The end behavior is going to be the same direction, so it's also going to go south there. This is just some notes. All right, different examples of odd degree, even degree functions. You might look more at those in pre-calculus and calculus. And lastly, what we're going to do together is there is a 25 at the bottom and a 4. 25 and a 4. All right, so for each graph, determine whether it's an odd or even degree function and how many zeros it has. Well, folks, zeros, that's the easiest thing. That's how many times it crosses the x-axis, not y-axis, x-axis. It crosses the x-axis 1, 2, 3 times, so it has 3 zeros. Look at the end behavior. Up, down. Up, down is opposite. That means it is an odd degree function. These would be in the slam dunk section of your quiz. So this crosses the x-axis 2 times, so it has 2 zeros. You have the same end behavior. If you have the same end behavior, this function is even. Even degree on 11. Opposite end behavior. Yeah, the function is even degree, not, yep, even degree, even degree. All right, so 11, sorry. 11, it crosses the x-axis 3 times, so it has 3 zeros. And look at the end behavior. The end behavior is up, down. That's opposite. Opposite end behavior, odd degree. Take a look here, folks. Crosses the x-axis 2 times. It has 2 zeros. And lastly, you have the same end behavior. Same end behavior means it is even degree. And folks, we did a good job there. That video is plenty of long for us. We will continue this tomorrow. This is Yak Math Videos signing out.